So welcome calculus to the great rain out of February 2022. Hope you're enjoying the rain and doing all the things that you do, building Rain Man, and all that kind of fun stuff. So yesterday we did 5.4 with definite integrals. Today we're doing a thing called indefinite integrals, which I've been advertising for a couple days. And the word indefinite sounds sort of scary, but it isn't. Indefinite integrals are much easier than definite integrals. Every integral you've done to this point of the chapter has been a definite integral. If you look around the board, if you were here, I'd ask you what's different about these compared to everything you've done before with integrals that's going to make these easier. And probably if you were here, quickly you'd observe that the numbers are gone. So every day we've done this, we've had numbers that we had to plug into equations of some sort. And that was like half the work, or sometimes more, depending on what we were plugging in and what the numbers were. The numbers are gone. So today we're just doing what we've been doing, but not having to plug in any numbers, which is pretty outstanding. If you knew the numbers, they're called definite because you definitely know the numbers, right? So today we don't know the numbers, these are just indefinite. They're a little bit more like multi-purpose. So if I asked you to do the integral of x to the 8th, we learned yesterday the word integral is just a synonym for antiderivative. So you've done questions like this at the end of chapter 4. The integral of x to the 8th, or the antiderivative of x to the 8th, just steps us up a power to x to the 9th. And then in the front, you divide by the new power, so there's a 1/9. And then we're back to our old good friend. The plus c replaces the need to plug in. So instead of plugging in, you just have to remember to put a plus c. And we're golden. And that's it. That's what we do. We'll do a few more problems just to seal that in, but that's the deal today. Yesterday was antiderivative and then plug in. Today's antiderivative and plus c. It's worth pointing out there's a table 5.4 that is on page 314, and it gives you some nice things on there that are probably worth going on your card. I don't know that integration formula number 1 on page 314 is worth going on the card. It's just what we did here. They use some symbols to explain the rule of power goes up 1 and you divide by the new power. But some of the tricky things are probably worth going on your card. You could put on there that the derivative of sine is cosine. And now we could say likewise that the antiderivative of cosine is sine. And that's in here. That's like rule number 3 in this table 5.4. And they even go you one better and say if we slip in an 8, we need to leave the 8 and therefore divide by 8. And it's up to your style. The book style seems to be to put this x to the 9th over 9. My style is more frequently putting a fraction in front. It doesn't matter. So if this is a 1/8 in front or an 8 on the bottom, that's up to you. But table 3, the table 5.4 has some nice trig stuff on 314. There's also a table 5.5, which is worth a mention, but isn't card worthy maybe. The table 5.5 is just telling you, like, for number 1, if you do the integral of a derivative, you just get back to where you started. And 2 is telling you if you do the derivative of an integral, you would just get back to where you started, because they're opposites. Like adding and subtracting are opposites. Whatever, due to one side, due to the other, equations are like a scale, back to that whole lesson from the old days. Derivatives and integrals are just opposites. So a point of emphasis there is that you can check these integrals by doing the derivative. And you can check derivatives by doing integrals. 3 is just telling you if they sneak a number into the problem, the number can basically be ignored and multiply later. Like if I went back to this problem and threw a 10, whether I put the 10 out in the front or whether I put the 10 like within the integral problem, all that's going to do is get you a 10 hanging around and the answer is right. Rule 4 is telling you if there's negatives involved, you just bring them along for the ride as well. So whether I put a negative here or put a negative there, tacking a negative in the problem just tacks a negative into the answer. 5 and 6 is also just telling you that if adding or subtracting get involved, just do each piece on its own, and then they're still going to just be adding or subtracting. So here's another one to do. Antiderivative of sine turns into cosine. When we work in that direction, we will get a negative going on. If you don't believe me, look at rule number 2 on page 314, and that'll straighten out for you when you do or don't change the sign on this tricky stuff. The argument never changes when you do derivatives. So if this has a 2x, this has a 2x. But because of the 2x that has a derivative of 2, we need to get a half going on in there. And our good friend the plus c. We move on with our day. And again, if you wanted to check this, if you do the derivative of cosine, it's negative sine, which turns this negative back into a positive and a sine. And the chain rule would make you multiply by a 2, because that's the derivative of the argument. 2 times that would just wipe it out. Derivatives, check integrals, integrals, check derivatives. For this one, integral of secant tangent is just secant. If you don't believe me, look at rule number 6 on page 314 on that. There's nothing in the arguments cluttering them up, so all you need to do is remember the negative 7 is going to come along for the ride, and tack on a plus c. If this had like a 5 or something, this better have a 5 as well. They have to be consistent throughout the problem. So if these both had 5s, we would need a 5, and then it would be 7/5. This, we've got some adding or subtracting going on, so we'll just take it a piece at a time. X cubed goes up to x4, and divided by the new power, so 1/4. This x goes up from a divisible 1 to a 2. Divide the old number by the new power, and now that's a 1 that I don't want to write. Basic numbers in our antiderivative past always just gained x's. And then we go plus c, and on with our day. The last 2 things that are worth a mention on page 317, they do out 2 problems with like a whole bunch of steps. And I don't care to do those. I'll just tell you, the integral of sine squared and the integral of cosine squared should go on your card. It'll help you in the homework, it'll help you on the quiz, it'll help us in future chapters. The integral of sine squared is in the middle of page 317. They have integral of sine squared equals blah, 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 work, 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 we don't care, we don't care. Just cut to the very last thing and put that on your card, that the integral of sine squared equals that very last thing. Then the integral of cosine squared on the lower question equals that very last thing. You don't need any of the work or the blue or the steps, just kind of cut to the bottom line. And then we're working page 319. Syllabus will know what to do on page 319. My paper is strewn about here somewhere, and I don't feel like walking off camera and finding it. But I think we skipped 3s. I think it's for like 38 or so, something like that, if I'm remembering this right. But the syllabus will know what to do on 319. Is that my paper there? Yeah, this will do it. 319. Okay, it's in 2 portions. There's a 319. We do skip the 3s to 38. But then we kick back in from 39 to 55 doing odds. 39 to 48 is just emphasizing the idea. They give you a problem that's done and they want you to check it by doing the derivative, which we talked about. If they did the integral, do the derivative to check them. And then from 49 to 55, we need to have a flashback to chapter 4, how we had what was called initial value problems, where we figured out what the plus c was. So they're going to give you some information to plug in for x's and such, and do a little algebra that you'll be able to come up with what the c is on those last few, just like we did at the very end of chapter 4. We've done those questions before. So that does it for today. We'll see you when all this terrible drizzle finally runs its course and we can come out and function in society again. See you guys.